Hey class, it's Andrew, and today we're going to be talking about logs. Logs are a hot topic in mathematics, and there's a lot to cover, so let's get started. Alright, so I'm sure you guys could tell by now, but we're not actually talking about tree logs today. Instead, we're going to be talking about logarithmic functions. But before we do that, let's review what an exponential function is. So an exponential function is a function where b is a positive real number and the variable x occurs as an exponent. In this case, we have b raised to the power of x is equal to y, and we can see that represented here graphically. So for your do now, I want you guys to try finding the exponent x for these two problems. Take a minute and pause the video if you need. Alright, so hopefully you've done that. Now let's check our work. So for number 1, x is going to be equal to 2, and for number 2, x is going to be equal to 3, because 3 raised to the power of 2 would be 9, and 2 raised to the power of 3 would be 8. Alright, so hopefully you guys got that. Now let's discuss how this relates to logarithms. Alright, so as you guys can see above, logarithmic functions are just inverse functions of exponential functions. So if you look to the right, you can see the exponential form of b raised to the power of y is equal to x. And if you look to the left, you can see that the logarithmic form, log sub b or log base b of x is equal to y. So really what this is saying is that if we applied log base b to both sides of the exponential form, then log base b and b would cancel each other out to just give us y, and then we would be left with log base b of x is equal to y. So let's look at some examples. Alright, so here are a couple of examples. We have log base 10 of 1,000, or another way of writing that would just be log of 1,000, because if we don't see a subscript, we automatically assume that it's in base 10. And we set that equal to x. And then we have log base 25 of 5 is equal to x. Now, when you're thinking about this, think about 10 raised to what power gives us 1,000, and 25 raised to what power gives us 5. So that's how we should be thinking about these logarithmic functions to solve for x. So take a minute, solve for yourself, or if you just want to see the show, let's take a look. So here we have log base 10 of 1,000 is equal to 3, because 10 raised to the power of 3 is 1,000. And then log base 25 of 5 is equal to 1/2, because remember, the exponent 1/2 is just the same as taking the square root of a number. So the square root of 25 is equal to 5. Okay, so now that we've discussed that, try this next one for yourself. Log base 2 of x is equal to -1. So try solving for x. Take a minute and do so now. Alright, so here's the work. What we're going to want to do is we're going to want to apply base 2 to both sides. So now both of these are going to become exponents. So we have 2 raised to the power of log base 2 of x is equal to 2 to the power of -1. And so this 2 and log base 2 are going to cancel each other out because they're inverse functions of each other. And so that's really just going to leave us with x is equal to 1/2. Alright, so here's another example for you guys. We have log base x of 16 is equal to 2. Take a minute to solve this, but if you need a hint, think about it this way. What base raised to the power of 2 is equal to 16? Take a minute, solve that now. So hopefully you guys have tried this yourselves. Now let's take a look. So to each side, we're going to apply base x. So we'll notice that here, x and log base x are going to cancel each other, and that's going to leave us with 16 is equal to base x raised to the power 2. So 16 is equal to x squared, and what numbers does that work for? Well, we have x is equal to 4, and we technically also could take x is equal to -4, but we're not going to take negative bases when we're dealing with logs. Now that we've discussed what logarithms are, let's discuss some of the rules that are applied to them. So I'm not actually going to prove any of these rules, but if you're interested, I'll include a link in the description below that's going to have a lot of these proofs. But if you're just interested in knowing the rules, let's get started. So the first one we're going to discuss is the logarithmic power rule. So the log power rule states that log base b of x raised to the power of y is going to be equal to y times log base b of x. And here we're just using b as a generic base. It could be any number, really. The next one we're going to discuss is the logarithm product rule, which states that log of x times y is equal to log of x plus log of y. Then we have the logarithm quotient rule. So instead of multiplying two numbers, we're going to divide two numbers. So log of x divided by y is equal to log of x minus log of y. Finally, we're going to discuss changing log bases. So to change a logarithmic base, what we're going to do is we're going to take log base c of x divided by log base c of b, and that will give us log base b of x. So it's important that log c of b is going to be on the bottom because whatever you want on the base needs to be at the bottom. Think about it that way. Here's a table of the rules that we just went over and the formulas that accompany them. So you should pause the video now and write these down because they'll be useful when we're solving problems in a second. Here are some problems for you guys to practice the rules that we've just gone over. So I will post the answers to these in the Google Classroom later this week, so make sure to keep checking that out. Also, if you enjoyed this video, if you feel like you've learned something, please like and share it with your friends. And also make sure to check the links in the description below to continue learning about logarithms. As always, be sure to keep checking out Abarso ASAP, subscribe to the channel, and I hope to see you guys soon.